Greetings, fellow dev! This video is the first in a series where we'll be developing a scalable, flexible, modular, event-driven, data-driven coffee-making adventure game framework for Unreal Engine. So I will first focus on the interaction system, which is a widely addressed topic in Unreal tutorials with plenty of quality content available on YouTube. But I want to show a slightly different approach, especially concerning detection of interactable actors. Typically, this is done by raycasting, with either a line trace or a sphere trace by channel, starting from the camera location and following its forward vector. It's a perfectly valid approach, but it can be frustrating when you have a clutter of interactable and want to select a specific one. Your sphere trace might collide with every other object and not the one you want. You can reduce the radius in case of a sphere trace or switch to a line trace for pixel-perfect precision. But it will become an exercise in frustration if the object is small or weirdly shaped, especially if you play with a controller. The way I will do it is by first creating a custom object channel dedicated to interactable actors. This is done by going Edit, Project Settings, Engine, Collision. As you can see, I have already created a custom channel called Interactable while preparing this video, and didn't remove it because Unreal is quite the diva with that and it might throw a tantrum. Anyway, we create a custom object channel that we will call whatever we want, and set the default response to block. I have created a generic interactable actor blueprint that is basically nothing more than a simple static cube mesh. We are going to change the collision settings of this mesh, and set the preset to custom. Then, in the object type, we can see that the custom object channel we have created has appeared, so we set it to interactable. Let's now move to the first-person character blueprint. Remove all the trash and create a function that we will call detect interactables at location. It will take for input a vector detection location and an output array of actor references, detected interactables. This function will run on the tick event. I know I'm going to take some flack for that because people hate putting calculations on ticks, but it can be easily transferred to a timer if it happens to be consuming too much CPU performance, and it's good enough for demonstration purposes. We connect the world location of the camera component to the function input. I want to keep it as an input instead of a hard-coded value, so it can be directly used for other game genre, like for point-and-click with a fixed camera, for instance. Let's implement the function. We first create a local array variable, actor references. I will clear it at the beginning because I feel safer doing so, even though it's most likely useless. Let's go for a multi-sphere trace for objects now. We will feed the input location vector to both the start and the end pins, because I want to have detection in all directions at the same time. Let's promote the radius to a variable that we will call interaction range. Set as a config variable and in a category interaction, pipe, settings, pipe, detection. Compile and set a default value of 150. We drag from the object type's input pin and make an array with only one value inside, the interactable type we defined previously. Trace is set to complex and we activate draw debug for one frame. Let's drag the outIts output and process it with a for each loop. For every array element, we break the hit result. Out of sheer paranoia, I will check that the hit actor is valid and that it is a blocking hit. to ensure the reference isn't garbage before adding it as a unique entry to the detected actor array. For good measure, we will print the display name of the current hit actor with the duration of 0, so it only lasts for the current frame. Let's also draw a vertical debug arrow above each of them. It will become clear why I do this in a few seconds. Finally, we finish the function by connecting the return node to the completed pin of the for each loop and feed the detected actor local variable to the input of the node. Phew, let's give it a try. It seems to work perfectly. We detect all the interactable objects within the radius of the sphere. That's good, but there is no selection yet, and we can see, thanks to the debug arrows, that one object is being detected despite being hidden behind a wall. We will see calling and identification of the most suitable interactable in the next video, as I want to keep this one short and address things one by one in this series. In the meantime, I invite you to check out the demo of Asthenia that is available on Steam. It's a dark fantasy game for which I'm providing some programming support to otherwise solo developer Mantos Lapa, the handsome Greek god of blueprint spaghetti. I hope you enjoyed this video. If so, you know the drill. Please like, leave a comment, subscribe and sacrifice a goat to whichever deity you worship. In case you haven't noticed,
I'm French!
So sorry about the accent and see you next time!